Welcome back. This is part two of this lesson. We did part A up to here. If maybe you're joining us just for part two, you may see that we found our OA to be equals to 25 centimeters. You can pause the video here and try to see how we calculated our OA, which is the radius. OA, OP, OQ, OB are all the radii of what? Of this circle. Right. Now, O is the center. PQ and AB are both the chords of the circle with OM perpendicular to PQ and OC perpendicular to AB. OM is 5 centimeters, OC is 7 centimeters, and AB is 48 centimeters. Check that because the units are on the other side. And then calculate the length of PQ. So now we got our OA, isn't it? Which was 25 units, 25 centimeters. Then here with 24 centimeters, here with 24 centimeters. Right, now we are saying that OP is also the radii, OQ is also the radii, and then OB is also the radii. So we can even write that one down and say OA is equals to OB is equals to OP is equals to OQ because they are what? And they are all equal to 25 centimeters because they are radii. You see that? Right, so they are all equal to 25. So we're asked to find PQ, and then we know that PM is equals to MQ. PM is equals to MQ. Why? Because it's a line from center perpendicular to chord, right? Because OM is perpendicular to PQ, right? So it means PM is equals to MQ. So if we find PM, then we found PQ. If we find MQ, you find PM, and then we can easily find our PQ by multiplying by 2. Let me use this side. We say this side, this is also 25 because the other side is like clustered, and then this is 5. So we can use triangle. In triangle, OMQ. Using triangle OMQ, we can say that OQ squared is equals to MO squared plus what? Plus MQ squared. Okay, why? Pythagoras. Or you can write path theorem. Still fine. Right? OQ is 25 squared is equals to 5 squared plus MQ squared. Right, now we can say 25 squared minus 5 squared is equals to MQ squared. I've transposed there. And then we can square root both sides. We can square root both sides here as it is. You can put it in your calculator as it is. Don't need to waste time. Right, just say square root of this and square root of that. So square root of MQ squared is what? Is MQ, isn't it? Square root of MQ squared is MQ. So what is square root of 25 squared minus 5 squared? Okay, if I put this in the calculator, I get 10 root 6. Is it centimeters? Yes, units and centimeters. Centimeters is equals to MQ. Right, so it means here this is 10 root 6 centimeters. This is also 10 root 6 centimeters. So the question said find PQ. So you can multiply this by 2. Okay, so therefore PQ is equal to 2 times 10 root 6, which is 20 root 6 centimeters. Remember, it's, the says you treat them like what? Like the variables. Okay, like variables, when you're saying 2 times 10x, you get 20x. Or even adding them, you can treat them like terms. You say 10 root 6 plus 10 root 6. Okay, you treat them like terms. You get 20, what am I writing here? It's 20 root 6 centimeters. So PQ is 20 root 6 centimeters. Okay, let's go to our, it's almost the last question. It has two parts, first part and second part, then we'll be done. Okay, I want you to try this for 1 minute. Okay, let's try. What did you get? OE. Let's check here. You see, but it's very fun. I don't know what we call this. Is it illusions or what? OE looks longer. Do you see that? OE looks longer than OB and OA. Okay, right. OE looks longer than OB and OA, but they are actually equal because these are radii. These are radii. You see that? Okay, so OE is equals to OB is equals to OA. You see that? Because they are radii. So now we're told that this ED is X, it is 8 centimeters, DO is X. So it means OE is 8 plus X, meaning that OB also is 8 plus X. So OB, therefore OB is equals to 8 plus X. So it means OE is 8 plus X, OA is 8 plus X, and OB is also 8 plus X. So we can even write here, because it's clear at this side, so we can write here 8 plus X. Even here we can write 8 plus X. You see that? Okay, right, we're done with the first part. Now we know that the radius is 8 plus X. I want us now to find, it says what? The information is still the same. Hence, calculate the length of radius. Now we want the length, not in terms of X. We have to find the length of the radius. And I want you to spend what? 5 minutes on that. Now we know that. Let's write our information. We said here is 8 plus X, and then here 8 plus X. Let's try. Let's do it together. AB is the chord of the circle, right? OE bisects AB. Very important. Center theorem here. Okay, and then AD equals to 12 centimeters, ED is equal to 8 centimeters, and OD is equal to X. Determine the radius OB in terms of X. Hence, calculate the length of radius OB. We've done the first part. We say that our radius was 8 plus X, and then here 8 plus X. Even OE is 8 plus X, right? So we want to find the radius of what? The radius OB. Okay. So now, what do we have? OE bisect what? AB. So it means it cuts AB into two equal parts, meaning that this is the midpoint. This is the midpoint. Therefore, this angle and this angle are right angles. So let's name them D1 and D2. So it means D1 is equal to 90 degrees. Why? Because of line from center to midpoint of chord. Line from center to midpoint of chord. So now it means now we have a right angle triangle here. ADO is a right angle triangle. Right, I'm going to concentrate on this triangle ADO. Why? Because I have the 12 there. But I can also use this. Remember, I'm finding OP. They said find OP. But when you find AD, we have found OP because we're given that they are equal, isn't it? So we can do either way. It's fine. Right now, what else do we have? What do you want to talk about? Right now, okay, this is a right angle triangle. So it means we can use the Pythagoras theorem to find the radius OA. Okay, to find the radius OA. So we can say OA squared is equals to DO squared plus AD squared. Why? Because it's Pythagoras. Right, and then let's substitute. What is OA? We don't have that. We're looking for it. We're going to put our 8. We can even put 8 plus X now, but let's do it later. I want to just separate these two things. Then is equals to DO. What is DO? Is X squared and then plus 12 squared. You see that? And then And then we can what? We can say this is OA. I said I want to separate them, but if you want, we can put our a plus x straight away there. Right, let me show you the approach that I'm going to use. OA is equals to the square root of x squared plus 144. Okay, right. Now, and then let's put our 8 plus x, because we know that OA is 8 plus x. So it's going to say 8 plus x is equals to x squared plus 144. Okay, right. Now we have a surd equation here. Remember that surd, S-U-R-D. Okay, say surd. Right, and then we square root both sides, because we have to isolate the surd. It's already on the right hand side, so we can easily square both sides here. Let me pick my color for doing these other operations. So I square here, and then I square there. Okay, you see that? We square both sides. We square both sides, and then what are we going to get? I'm trying to pick the color, it's not coming up. Right, and then, right, now we have 8 plus x squared is equals to, then the square root and the square, they cancel each other out. It's going to be x squared plus 144. Okay, right. And then what we have here, we have to simplify, to expand this. We can't solve an equation when it's like this. We need to expand that. How do we expand this? Let me show you the method, the FOIL method. Then I'll show you the other method of the easy method of what? Of expanding or multiplying, finding the product of square binomials. Right. 8 plus x. I've seen this common mistake a lot. I don't know why. 8 plus x means what? 8 plus x squared means what? It means 8 plus x times 8 plus x. That's what it means, isn't it? I've seen people just squaring 8 and squaring x and saying they've expanded. No, we can't do that. Okay, and then we use the FOIL method. 8 times 8 is 64. Then 8 times x plus 8x. X times 8 is plus 8x. Then x times x is plus x squared. You see that? Okay. And then you can simplify this to 64 plus 16x plus x squared. And then we can put it here. But let me show you the other method which you can use to expand a square binomial. So now what you do, you square the first term. Let's call it 8 first term and x second term. So you square the first term, which is 64. 8 squared is 64. You take the sign between the terms, which is positive, which is plus. You put it here. And then the second step, you multiply term 1 and term 2 with what? With 2. So you say 2 times 8 times x, you get 16x. And then the last part, the last sign is always positive, and then you square the last term, the second term, which is x squared. You see, we're getting the same thing as that. We're getting the same thing as that. You see that? So it is faster if you're squaring what? If you're dealing with square binomials. And then we say x squared plus 144 here. Right, and then if you have two terms that are the same on the opposite sides of the equal sign, you can as well just cancel them. X squared and x squared, they go. We remain with a linear equation. You see that? Because anyway, you can transpose your x squared to come this side. It becomes x squared minus x squared, which is 0. Right, and then we remain with 16x. Then I'll bring the 64 to the other side, which is 144 minus 64. 144 minus 44 is 100 minus the 20 is 80. 80. Right, it should be centimeters. Then we divide both sides by 16. We get what? 16 divided 16x divided by 16 is x is equal to 5 centimeters. Right, now let's check our question. Hence calculate the length of the radius OP. Okay, so many people find people ending here. We haven't answered the question. They said must find the radius what of OP. So therefore OB is going to be 8 plus x is going to be 8 plus 5, which is OB. I don't like writing equal sign without the equation must have both sides. And then, so OB is equal to what? Is equals to 13 centimeters. 8 plus 5 is 13 centimeters. Done. I would like to show you the other way of doing this. Like I said, right, let's say here we know that triangle, triangle, in triangle what? AOD. We know that triangle AOD is a what? It's a right angle triangle. So we can say that OA squared is equals to OD squared plus 8D squared. Okay, so now I want to substitute this 8 plus x once into the where there's OA there. So I can say 8 plus x squared is equals to OD, which is x squared, OD squared, which is x squared, plus 8D, which is 12 squared. Okay, so if you check here, we can expand this and get 64 plus 16x plus x squared, like the way I showed you in the previous one, which is equal to x squared plus 144. Then x squared and x squared go, we remain with 16x, and then if we transpose, and then we say 144 minus 64, you get 80. See that this one is faster, isn't it? And then divide by 16 there, divide by 16 there, we get that x is equals to 5. Therefore, OB is equals to 8 plus 5. So OB is equals to 13 centimeters. Okay, right. Now let's do the last question. The last question says, AB is a chord of the circle with center O. AC is equals to CB, and the length of the radius is 5 units. AC is 3 units and OC is 4 units. Show that OC is perpendicular to AB and explain why OC passes through the center of the circle. Right, remember the Pythagoras theorem. So here's the converse. Right, we're saying that if this is a right angle, let's say this, if this is the right angle, right angle triangle, sorry, right angle triangle ABC, we'll say AC squared is equals to BC squared plus AB squared, isn't it? That's the Pythagoras theorem. So now, if we have a triangle, let's say we don't know that this angle is what? Is 90. Let's say this is DEF. We have a triangle here. We don't know that this angle is 90. But if DF squared is equals to DE squared plus EF squared, then we can conclude and say this angle is 90 degrees. Okay, so this is what we have to do here. So we have to use our triangle ACO. If we prove that triangle ACO is a right angle triangle, sorry, if we prove that if we prove that AO squared is equals to AC squared plus OC squared, then we have proved that C1 is a 90-degree angle, or is a right angle. You see that? So let's try to do that. Let's have our left-hand side and right-hand side. Okay, so we have our OA squared and we have our AC squared plus OC squared. Right, now we have 5 squared here, and then we have 3 squared this side plus 4 squared here. And then this is 25, this is 25. So we prove that the right hand side is equals to the left hand side. So therefore, left hand side is equals to right hand side. So we prove that this is a right angle triangle. Therefore, C1, angle C1 is equal to 90 degrees. Okay, meaning that OC is perpendicular to AB. So we've done that. And then it says, and explain why OC passes through the center. So now from this, we can conclude and say OC is a perpendicular bisector of the chord.